So here's a recap of everything that we've learned so far when it comes to hailstorms. In lesson 2, we looked at weather data for different hailstorms across the country. We saw that the temperature was never below freezing, and we agreed then that hail must form up here in the clouds since it's not cold enough on the ground for the water to freeze. Then we looked at lesson 3, and you looked at weather balloon data and what's happening to the atmosphere, the temperature, and the molecules of gas in the atmosphere as you go up. And we found that it is warmer, closer to the ground, and colder higher up temperature wise. And we know that's because the gas is thinner the higher up that you go. So if we zoom in on the gas that makes up our atmosphere, we would see they're closer together down here where it's warmer, and they're moving in all directions. I'll make a little key down here. We'll just call those gas particles to represent all of the gases that are in our atmosphere. And then higher up, we know the air is thinner. That's why it's colder, so there are fewer molecules moving around, and that makes it colder. Then in lesson 4, we saw that the sun is the energy source, and that energy is coming down to the surface. Some of it is being reflected, and some is being absorbed. And the lighter colors reflect more energy, and darker colors absorb more energy. And we were able to collect that data because the darker surfaces got warmer than the lighter surfaces. Surfaces that were in the sun got a higher temperature than surfaces in the shade. And going back to lesson 2, we also figured out not only does hail have to form in the clouds, but that water vapor plays a role. We saw that the humidity decreased before the storm, so we know that there has to be water vapor in the air. So if you do a zoom in, and some of the percentages were pretty high for the water vapor, we know that there has to be water in gas form in the air during a hailstorm. So we'll add that into our key for water molecules. Then in lesson 5, we figured out that air, when heated, will change density. So this warm surface down here is going to heat the air, and the air above it's going to speed up. So if we zoom in, we know that those gas particles in the air are going to start speeding up. So they're going to be moving faster. They're going to be able to get farther away from each other. They're more spread out. And that means that they are going to rise because they're less dense than the air around it. So they're going to rise because this parcel of air is less dense than the surrounding air. And then as it's rising, it's going to transfer energy to the surrounding cooler air and then sink. So if we zoom in up here, after this parcel of air has had time to rise, we would see that the air has cooled. The particles are going to get closer together. They're moving slower. So I'm going to draw smaller arrows. This is going to make them more dense, and it will start to sink, which is what we saw with the balloon in lesson 5. So it's going to sink because it's more dense. So that is a recap of lessons 2 through 5 for what we figured out so far.